Okay, so this is for 4.5c. Number one, they want you to solve it by factoring. So the first thing that you want to do is make sure that all the terms are moved over to one side, and try to make sure that the side that you move it on is the side that has the lead term positive. So right now, this lead term is positive where it's at. It's positive 2x squared. So I'm going to move these two values, or these two terms, to the left. So I'm going to have 2x squared. I'm going to be adding 5x to both sides. So I have plus 5x. And I'm going to be subtracting 12 from both sides. Then you want to check the order. The order is great. The lead term is positive. That's what we want. There's no greatest common factor. It's not a perfect square trinomial. So then we just have to factor this. So we're going to use the box method. So the lead term is in the upper left, constant in the bottom right. 2 times 12 is 24, so that's our AC. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6. The signs tell us they're different. The larger one's going to be positive. So these are positive. These are negative. Which one adds up to 5x? It would be this one right here. So negative 3x and positive 8x. So this is positive, positive, positive. This is negative, so we put a negative here. So factor out the greatest common factor. So this is a 4. This would be x. This would be 2x. And this would be 3. So we have 2x minus 3. X plus 4 equals 0. So now what you want to do is you want to take both of these and set them equal to 0. So 2x minus 3 equals 0, and x plus 4 equals 0. And then solve. You add 3, divide by 2, so that means x is 3 halves. This one you're just going to subtract 4, so x is negative 4. So let's write these in set notation. So write our answer up here in order from least to greatest, so negative 4 and 3 halves is your answer. Number 2, we want to move everything on one side. So the lead coefficient's here and it's positive, so we want to leave that here. So let's move the 21x to the left. Next step is factoring out the GCF. So we have a GCF of 7 and an x. So that leaves us an x minus 3 in parentheses. Now that we're done factoring these, we want to set each of these up equal to 0. And then solve for x. So divide by 7, you get 0. Add 3, you get 3. Least to greatest, 0 and 3. Number 3, we're going to be graphing. So let's move this over, get our calculator out. So let's plug this in. 3x squared plus 2x. And then this 2 over here, we're going to be moving to the left-hand side. So it's going to be minus 2. So we hit graph. And we want to find these two solutions. So second trace 2, because we want to find the zeros. Left bound, so we want to do just above the x-axis. The right bound just under it. Then hit enter. So we're going to have negative 1.22 roughly, so that's that one. Then this one, we hit second trace 2 one more time. So any spot just before it, and then any spot just after it. and then enter again. So you'll get roughly 0.55. So let's write those as the answers. So negative 1.22 and 0.55. Number 4 is a squirrel jump. So let's clear out the equation. Type this one in. Negative 0.068 x squared plus 0.48 x. Hit graph. So what we might want to do is we might want to limit the y values, just to focus in on this. So let's make the y values from negative 5 to 5. There, so that's a little bit better. So how far did he jump? So we want to find out this 0 right here. So second trace 2. Left bound is going to be anywhere just before. Right bound anywhere just after. And then guess. It's going to be 7.06. How high did he jump? Let's get the calculator back. So for the height, the y value is going to be the height. The x value was how far, the distance that he jumped. So the vertically we want to, he peaks at this point right over here. So that's at the vertex. So we want to look at the y value of the vertex. So we want to hit second trace 4 because we want to find the maximum point. So left bound is going to be anywhere to the left of the vertex. Right bound anywhere to the right of the vertex. And then guess. Remember, it's the output of the vertex. So 0.85 is your answer. Alright, number 6. So these are the zeros, 2/3 and negative 6. They come from a factorization. The negative 6 comes from x plus 6. This comes from 3x minus 2. And the reason why we know that is because the denominator is always the coefficient of x. You take the opposite of the sign, just like we did here. The negative became a positive. The positive over here became a negative. And then the numerator always comes afterwards. So 3x minus 2 times x plus 6. Let's multiply this out. So we FOIL it out. So 3x squared plus 18x minus 2x minus 12. So 3x squared plus 16x minus 12. So this is our function for that problem. Alright, for number 7, they want you to just factor that expression. Before you go hog wild and start, doing trial and error or the box method or anything, follow the steps. Is it in order? Yes. Is there a greatest common factor? No. Is the lead coefficient negative? No. So we're good in all of that. Is it special? Well, let's find out. This is a perfect square. It's x. This is a perfect square. That's 5. If I multiply those, and then by 2 again, multiply it by 2 afterwards, do I get 10x? Yes. So it is special. It's x. Then you've got your 5. Then that sign drops down. So it's x minus 5 squared. All right, for number 8, we want to graph this parabola. So the vertex is going to be the opposite of b over 2a. So we have negative 5 over 2 times negative 1/2 is negative 1. So we have 5. as our h, or the x-coordinate of the vertex. So let's plug that in. So negative 1/2 times 5 squared plus 5 times 5 plus 1. So negative 1/2 times 25 plus 25 plus 1. Negative 1/2 times 25 is negative 25 halves. We could make this 50 halves. We could make the 1 2 halves. So when you add all those up, 52 over 2 minus 25 over 2 is 27 over 2, which is 13.5. So there's your vertex. So 5, 13.5 is above where we have this right now, because this only goes to 12. So now what we can do is we can just plot the y-axis intercept, which is 1 here. Let's plot the point of symmetry. So this is when x is 0. This point is when x was 5. So there's a difference of 5 here. So we want to move 5 units to the right and put a point. So we've got that. So now we just connect it all to a smooth parabola as best as you can, and there's the graph. This one's the absolute value equation. So the trick that we learned in class was, remember, if you want to call it the vertex, the point where the rays shoot off of or extend off of is the opposite of this sign. So positive 1 divided by a half. 1 divided by a half is the same as 1 times the reciprocal. So it's 2. So we're going to have 2, comma 3. That's the point that the rays extend off of. So from that point, we want to choose another one. I'm going to choose a point that is a factor of 2, so that when I multiply by a half, I'm not going to get a fraction. So I'm going to plug in 8. So y, let's just talk it out. Half of 8 is 4. 4 minus 1 is 3. Absolute value of 3 is 3, and 3 plus 3 is 6. So 8, comma 6 is a point on the graph. So 8 is 6 units to the right of 2, so I'm going to go 6 units to the left of 2. So that's going to be negative 4, and I'm going to have the same height. So it's going to be right here. I'm going to extend those straight lines, and that becomes your absolute value graph. Number 10. Explain in words what the domain would be for the function. So for number 4, if you remember, that was the one where the squirrel was jumping. He extended the full distance. Well, he started at 0, and he jumped and landed at around 7.06. So we're going to say that the domain is the set of all x's such that x is greater than or equal to 0, since that's where he starts, but less than or equal to 7.06, because that's the farthest he can jump. So the reasons, or writing it out in words, would be it has to be greater than or equal to 0 because he can't jump a negative distance. He starts at distance 0, that's his starting point. And it has to also be less than or equal to 7.06 because he can't jump further than that for this particular problem. And that's it.